In this example, we're trying to convert these alcohols to these sulfide compounds. Okay, and in both cases we're doing a substitution with SCH3, but in the first example we're going from an out alcohol to a back SCH3, so we're doing an inversion in configuration. In the second example, we're going from an out alcohol to an out SCH3, so we're retaining the configuration. So this is a retention. Okay, and as we work through this problem, keep in mind what we know about SN2 reactions. SN2 reactions go with inversion. So you might just want to think about doing an SN2 on this alcohol with SCH3-, but that's not going to work because remember, OH is a very poor leaving group. So we need to turn this into a good leaving group first. What we can do is treat this with tosyl chloride and pyridine. What this does is it forms an O-tosylate group. So it puts that tosylate on the oxygen. So we get this OTS. We don't have any change in configuration because we're only affecting a reaction directly on this oxygen. But now this OTS is a great leaving group. So from here, now we can treat this with a nucleophile to do our SN2 reaction. So what we can do is maybe treat this with NaSCH3. So this salt has the sodium cation, SCH3 anion, which is a good nucleophile. So now we can do an SN2. Remember, we get backside attack, so the SCH3 attacks from the backside, which is going to make it going back like we have in our product. And then we just lose the OTS as a leaving group. So here, we essentially just converted the OH to a good leaving group and then did an SN2 reaction to get our inversion. In this second example, we want to retain our configuration. Another way to think about retention is actually to think of it as a double inversion. So if we do one inversion to get a back group and then a second inversion to get an out group, which is net retention of configuration. So to do a double inversion, we're basically going to need to do two SN2 type processes. So one reaction we can use, we can convert this OH into a bromide using PBr3. The mechanism for this reaction involves bonding the oxygen with the PBr3, which turns that into a good leaving group, and then a Br that comes off the PBr3 acts as a nucleophile and displaces that through an SN2 reaction. So this is our first SN2. So we convert this alcohol to an alkyl bromide, and because it goes with inversion, the bromine goes back. Now we have something that has a back configuration, so a second inversion will get us our desired stereochemistry. So now we're set up to do a second SN2, and we'll use our same nucleophile as before, SCH3-. Now this goes with inversion. So if our bromine's pointing back, our nucleophile is going to end up pointing out as desired in this reaction. So it's really just thinking about what reaction conditions you need to use to affect your desired reaction and your desired stereochemistry.